All right, so for number 1, it says, which of the following represents a geometric sequence? Well, if we look at all of them, we could certainly go through and plug in numbers and see which one has an R value where you're multiplying to get to the next term. But anytime that there's an exponent here in your problem and it's exponential, you know that A is going to be your geometric sequence. Number 2, which of the following statements is true about the given series? So you're summing from 5 to 25 of this formula right here, negative 4n. Well, right away what I would do is I would try and find the number of terms. So I would say 25 minus 5 plus 1. Right? So that's going to give you, that equals 21 terms. Change the. So right there we know it's not C and it's not D. Now, in order to figure out whether it's arithmetic or geometric, now it doesn't have an exponent, so most likely it's going to be arithmetic, but if you want to check it, let's just plug in a couple of numbers here to see if it's arithmetic. So if I plug in 5, my first term, I get negative 20. My next term, 6, would give me negative 24. And my next term, 7, would give me negative 28. And right there we can tell we're going from negative 20 to negative 24 to negative 28. So we're getting smaller by 4 each time. So we're subtracting 4 each time. So it's going to be an arithmetic sequence. Let's slide down to number 3. All right, so we're given A2. We're given our second term equals 42. And we're given our nth term formula. All right, so let's fill this out. The second term we are given is 42. Right? Well, in order to figure out the first term, we can just say 42 equals this an minus 1 all over 6. Right? So I can say that my 42nd value is going to equal this, but n in this case is 2, right? So this would be equal to a 1 over 6. So then I just multiply both sides by 6, multiply by 6, and I get a1 is equal to 252, right? Now, using this formula, the a sub n minus 1 over 6, I can find the rest, right? My third term value is going to be the the previous term. That's what a sub n minus 1 means. The previous term, so 42 divided by 6, so that's going to be 7. My fourth term is going to be my previous term divided by 6, so that's going to be 7 over 6. And then my fifth term is going to be my previous term divided by 6, right? And that's going to be 7 over 36. All right? Number 4, the arithmetic sequence where a1 equals 8 and the first term equals 8 and the fifth term equals negative 3 or negative 4. So we know the first term, let's just write it in. We know the fifth term, negative 4, right? Well, let's fill these in. Let's try and find our d, right? So our d is just going to be negative 4 minus 8 all over the difference of the term numbers. So 5 minus 1. And that gives us an answer of negative 12 over 4 or negative 3. So we know our D is negative 3. Well, if we know our D is negative 3, we just go 8 minus 3 is 5. 5 minus 3 is 2. 2 minus 3 is negative 1. And then negative 1 minus 3 gives you your negative 4. All right? Number 5, the geometric sequence where the third term equals 9 and r equals negative 1/2. All right? Well, if your third term equals 9 and your r is equal to negative 1/2, let's write this in. Third term equals 9, right? Well, I know that in my with my arithmetic or my geometric equations, the a sub n, I can say 9 equals, and I'm trying to find the first term, times my r, which is negative 1/2, all to the n minus 1 power. Well, the n in this case is 3, right? So 3 minus 1 or squared. And that's going to give me a1 equal to 36. So a1 is going to equal 36. Sorry, this is wrong. This is a3. Sorry. So then a1 equals 36, and now, based on my r value, which is negative 1/2, I know that to go from first term to second term, I need to multiply by negative 1/2. Well, 36 times negative 1/2 is going to give me negative 18. Then negative 18 times negative 1/2 is going to give me 9. 9 times negative 1/2 is going to give me negative 9 over 2. And then negative 9 over 2 times negative 1/2 is going to give me 9 over 4. All right. Now, number 6. The arithmetic sequence where the 8th term equals negative 20 and the 17th term equals negative 47. Well, right away we know we need to find our D value. So D is going to equal negative 47 minus a negative 20 all over 17 minus 8. And that's going to equal negative 3. So our D value is negative 3. Now let's try and find a1. Well, we know a couple of our terms. Let's choose the 8th term. So we say negative 20 equals a1 plus, well, this is the 8th term, so 8 minus 1 or times our D value, which is negative 3. And when we solve for that, we solve for a1, we get a1 equals 1. Well, now we know we can find our nth term formula just by plugging this information back into our a sub n formula, right? So we know an equals our first term, which is 1, plus our n minus 1, all times negative 3. All right? So you can write it like this, or you could have negative 3n, and this would come out to negative 3 times negative 1 would be 3, so this would be plus 4. Now, in order to find the 13th term, I simply plug the 13 into my formula here, right? So I plug 13 into this. Negative 3 times 13 is going to give me negative 39. Then plus 4 is going to give me negative 35. All right, number 7, the geometric sequence where the 4th term equals 16 and the 8th term equals 256. Well, we know it's a geometric sequence, so we're immediately trying to find our R value, right? Well, we would simply say 16 times R to the difference of these terms, which is 4, equals 256. And when I solve for R to the 4th equals 256 over 16. I take the cube the cube root of both of those, and my R value is going to be equal to 2. All right. So now to find my first term, I would simply put 16, plug it back into the formula. 16 equals my first term times 2 to the 3rd power, which is my n minus 1. My a sub 4, my 4th term, is what we're using here. So it would be n minus 1 or to the 3rd power. And I get my first term equal to 2. Well, now I know my first term and I know my R. I can simply plug it back in and say my first a sub n equals my first term times, well, my R is 2 times 2 to the n minus 1. And that would be my nth term formula. Now, if I'm trying to find my 13th term, I simply plug 13 back into this formula here. And I would have 2 times 2 to the 12th, because it's n minus 1. And that comes out to be 8,192.